This is the data set of the number of vaccinations per child that a sample of 9 children received in Samaru's area. This is an individual series data because each number here represents the data from one child. Let us find the mean of this data. Recall that we said that the arithmetic mean is a measure of central tendency that indicates the average value of the data set. So our task here is to simply find the average. The mean of an individual series is given by the formula. X bar is equal to the sum of the values in the dataset from the first value to the nth value or the last value of x divided by n. Here, x bar represents the mean of the sample. Sigma I equals to 1 to n is the sum of all the values from the first to the last. X of I is the index dataset value and n is the number of values or the size of the sample. So let us use this formula to find the mean of our dataset of the 9 children. So all these data values represent our x sub I, and our summation x sub I will then be the sum of all these data values. So we simply sum all the values together to get our numerator. And then we divide by n the number of values, which is 9. And this will be 25 divided by 9. And so our mean is 2.7. Easy peasy.
Let's do this. Median of individual series data for odd number of data points. This is the data set of the number of clinic visits in the last year of a sample of 9 children in Samaru's area. This is an individual series data because each number here represents the data from one child. Let's find the median of this data. Remember that we said the median is a measure of central tendency that indicates the middle point of a data set. So our task here is simply to find the middle point. To do this, we need to first arrange the data in ascending or descending order. I prefer the ascending order because it's just logical. So here we'll have 0, 1, 1, 1, 3, 3, 4, 5, and 7. That is 1, 2, 3, 4, 5, 6, 7, 8, and 9. So our number of data elements n is 9, and this is an odd number. Awesome. Now, because our data values are already arranged in order, it will be easy to pick out the middle value. All we need to know is its position. Well, there is a simple formula for this. The median position is given by n plus 1 divided by 2. Notice that there is a th up here. This means that whatever we find here is just the position of the median and not the median itself. So the median position will be n, which is 9, plus 1, all divided by 2. That's 10 divided by 2, which will give us 5. So our median is going to be on the 5th position. Awesome. So let's count. 1, 2, 3, 4, 5. And the value of our median is 3. Easy peasy. Now we can also do this using another method if the data set is not too large. I will not advise you to use the second method I'm about to show you if you have more than 20 data points in your data set, because that's too large and it may be unwieldy. I call this method the quick method. So as usual, we'll first arrange in ascending order, and since the median is the middle number and at the median value, half of the data values will lie below and the other half will lie above the median, right? So we can cancel out from each end to find out which data value is left in the middle after cancelling equal numbers from both sides. So let's cancel the first and the last, and then the second and the second to the last, and then this, and then finally this and this. And here you can see that our middle number is 3, and that's our median. Awesome. Now what happens when our data set is an even number of values? How to find the median for individual series data with even number of values. This is the individual series data of the number of times that 10 children were vaccinated in their lifetime. Let's find the median of this data. Recall that we said that the median is a measure of central tendency that indicates the middle point of the data set. So our task here is to find the middle point, right? To do this, we need to first arrange the data in ascending or descending order. I prefer the ascending order because it's just logical. So here we'll have 0, 1, 1, 2, 2, 3, 3, 4, 5, and 5. That's 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Awesome. So our number of data elements is 10, and this is an even number. Awesome. To find the position of the median value, we will use the same simple formula that says the median position is n plus 1 divided by 2. Notice that there is a th here. This means that whatever we find is the position of the median, not the median itself. So the median position will be n, which is 10 plus 1, all divided by 2. That's 11 divided by 2, which will give us 5.5. So our median is going to be in this position. Well, guess what? There is no 5.5 position. So we'll have to find the average of the values at the 5th as well as the 6th position. So let's count 1, 2, 3, 4, 5. So our 5th value is 2 and our 6th value is 3. The average of 2 and 3 is just 2 plus 3 divided by 2, and that will be 2.5. So our median is 2.5 kg. Easy peasy. Now we can also quickly do this using the quick method if the data is not too large. So since the median is the middle number, and at the median value, half of the data values will lie below the median value and the other half will lie above the median, right? So we'll need to first arrange this data in ascending order because that's the logical thing to do. And then we'll simply cancel from each end to find out which is the median or which is the median number. So let's cancel the first and the last. Let's do the second and the second to the last. Then this, and finally this and this. And guess what? We're left with two numbers. All right. So we will just find the average of 2 and 3 and get the median, and that will be 2.5. So our median is 2.5 kg. Easy peasy. Mode of individual series data. This is the data set of the number of vaccinations per child received by a sample of 9 children in Samaru's area. This is an individual series data because each number here represents the data from one child. Let's find the mode of this data. Recall that we said that the mode is a measure of central tendency that indicates the most frequent value of the dataset. So our task here is simply to find the most frequent value, right? To do this, we need to first arrange the data in ascending order so we can see all the same values together. Next, we observe to see which value has the highest frequency. For the first value, 0, it occurs only one time. For the second value, 1, it occurs 3 times. 3 occurs 2 times, while the fourth, fifth, and sixth values each occurred only once. So we can see clearly that the highest frequency is 3 and the value with the highest frequency is 1. So the mode number of visits is 1 visit. Easy peasy. If you found this video useful, don't forget to like, share, and subscribe for more quick statistical tips and tricks. And check out this video here if you want to learn how to easily compute the mode for discrete series data, or this other video here for the mode of continuous series data. And as always, thanks for watching.